Hey everyone, welcome back to another 458 video. Today, we're diving into something fun. Building a sumo robot using Lego Spike Prime.
If you've ever wondered what it takes to make a robot push others out of a ring, you're in the right place.
What makes a good sumo robot? Well, a sumo robot. It's all about strategy. You need a machine that can push others out of the rink while making sure it doesn't get pushed out itself.
To do that, we need a solid build, strong motors, and sensors that help the robot see the ring's boundaries and find opponents.
Think of it like it's part wrestling, part battle of wits, and all about making a robot that won't back down.
The code for the research team's robot was really well done and really benefited our win at the sumo challenge.
Did your team have to do anything? Did you team code anything?
Yeah, we coded stuff. It's just we had some technical difficulties during the coding process. One of our coders was away sick for 5 of the days, and we had to rely on our big brains to help us the rest of the way.
But could you tell me about how you were gonna stop to detect an ultrasonic sensor? Because that seemed very interesting, and I actually got really scared.
We added this deflector, or almost as people on our team called it, a scrambler, like how you scramble eggs.
Yeah, nice.
It was a scrambler where our ultrasonic feed was on the same as yours, so then when yours would try and detect us, it wouldn't detect us, and instead would just make you guys spin in circles, and if you guys spun in the circle for 60 seconds, it would count as our win.
Okay, so, what were the different strategies used? I think you were on table team 2. Was it more push power, or, agility, or, trick plays?
It was supposed to be get out of my way power, and it was kind of a bit of both. It's hit them while they're not looking type power.
Right.
Which bots can't see, so I mean that's
right. And so what would you label the scrambler as?
I'd label it as our one team's biggest advantage and basically our holy grail until research team fix it.
What were some common mistakes or things that may not have worked as planned in your design or your coding process while making your robots?
I could answer one. This one's about the coding process, and when we attached our color sensors, we didn't really think about what was around our color sensors. So, and since our wheels were so big, it kept leaning back and forth. And when it leaned back, it sensed black, so it went backwards. And then it leaned back again, so it kept sensing black until it just fell over. So it kept doing that. But then I had this one period of robotics that I could work on, and we spaced out the sensors so there were no more black parts. And yeah, I think that really helped.
What are some ways that you think you could have improved if you repeated the sumo battles?
I think we could have put our ultrasonic sensor in a more reliable place where it wasn't as open, or added another ultrasonic sensor because we had a useless motor that wasn't being used at all.
What do you think would have happened if you added 2 ultrasonic sensors?
I think
I can answer this. 2 ultrasonic sensors, so we wouldn't have probably been able to send you much faster, so we put one in the front, one at the back.
Well, that's what I meant. If you had one in the front and the one in the back, but then you could
Yeah, so the problem is we need to add another attachment on the back, too. So we could probably do that, and that might have been a better idea.
It's very interesting.
Yeah, and that way we could just sense people more fast by adding in some more code. I think my favorite sumo battle was probably the one against the grade 8s, because it was the one where you could really see where our robot performed.
Yeah, you guys really tested in strength there. It was almost like a moment of validation for you guys.
Yeah, you could see it was a pretty scary attachment the grade 8s had.
Yeah.
They had a saw attachment almost. And
Well, it wasn't a saw, it was more of like a flicky arm, but
yeah,
was
It
scary.
didn't even move though. I think the funniest part of the battles was the final round with the grade eights. It was very ominous, and we were lining
Very
up. This is
ominous.
gonna be it. If we won, we're not. So we run the robot. A robot takes 3 seconds just to give the other teams an advantage, and in those 3 seconds, the grade 8 robot rolls off the table, and that's how we win.
The funny thing is, you wouldn't have seen it in the montage video. It kept going, and it actually started to run away from the grade eights. It ran off the table.
Oh yeah, I saw that. You had to be there to watch it. It was almost sad, like, because there were 2 rounds of it. The first round, it drove off. The second round of it, the grade 8 bot drove at the winning bot,
It was too
and
scared.
it was just stuck there. And then the winning bot started moving, and it was so fast and so sad. But ultimately, that bot came out on top for one reason. It's wheels.
Yeah. Okay, so OT, what were some improvements or regrets from this sumo activity?
I mean, when we were building the robot, we added an extra motor that we thought we were going to use for the attachment, but we never ended up using it, so it added a lot of extra weight and energy for the build.
Yeah, I agree with that. We could have used that port towards something like an extra ultrasonic sensor or a push sensor instead.
Or we could have created a whole new attachment.
Exactly.
It also took up space for an ultrasonic sensor, and that's why Table Team 2 took control of our sensor. So, yeah, I think she has a good point there. Thank you guys so much for listening. Honestly, thank you for your support. Make sure to subscribe and like the video. It really means a lot for us for FLO team, and we hope to see you in the next one.